Scenario: there are three ways an object can be launched off a cliff of an unknown height that is shown below. The launch speed here is v is equal to 4 meters per second. The trial 1 shows the object going straight horizontally. Trial 2 shows it being launched with a 45 degrees of elevation. Then trial 3 shows it a 45 degrees of depression pointing downwards. The question: you're going to calculate the magnitude of the horizontal component of the velocity, then rank them. The horizontal component can be defined by Vx is equal to that velocity times the cosine. The cosine part here is your adjacent vector. That's the reason why it's V times cosine theta. So for trial 1, plug in the 0 for the theta. You should get 4 meters per second. That makes sense because the theta was 0. It was completely horizontal. Then in trial 2, you plug in the cosine of 45. That's going to be 2.8 meters per second. And then for the third trial, it is still 45. It's not negative in any way because it says magnitude. And that's also going to be 2.8 meters per second. Those two are the same because their thetas are the same. So now you rank them, it should be in that order. The reason why trial 1 is greater is because it is purely horizontal. There isn't any part that was lost. Now, if you want to look at the vertical component, it would be v in the y direction is the velocity times the sine part of theta. The sine part here is the opposite. That's why it's v times sine theta. So plug it in. 4 times sine of 0. Sine of 0 is just 0 because there is no vertical part in trial 1. In trial 2, you plug that in, you get 2.8, which is the same. Cosine of 45 and sine of 45 are the same exact value. Same thing for trial 3. Now we want to rearrange it so we can rank them. So the completely horizontal for trial 1 goes last. The first two now are the same, which are going to be greater than the last one.